Everyone is exposed to radiation, be it naturally or man-made. 82% of it is from nature, such as plants, air, and the sun, and 18% is man-made, such as from nuclear bombs in the past. But what causes this and how? The answer would be radioactive decay. It is the property of atoms with unstable nuclei where the atoms transition from parent nucleotides to more stable daughter nucleotides. Unstable nuclei elements are considered radioactive. So how is this property expressed? That would be the half-life, which is the time it takes for half of the radioactive element to decay. And how was it discovered? Its discovery was first proposed by Henri Becquerel, a French engineer and physicist, who experimented by placing a photographic plate wrapped in opaque paper with a phosphorescent crystal on it. The crystal is excited by sunlight for hours and left. Even with the opaque paper to block visible light, there were silhouettes of the crystal on the photographic paper, hence the presence of radiation. The technological advances the world have today would not exist without the mathematics in radioactive decay.
When looking at radioactive decay, we use mathematics and statistics to turn experimental data into useful equations and relationships. These help us model and understand this natural phenomena, as well as make useful predictions that have proved vital in a number of fields. This is the equation most commonly seen when modeling radioactive decay, where n is the amount of a substance at time t, E is the constant Euler's number, lambda is the decay constant of the substance, and n0 is the initial amount of substance. But how was this equation formed? Using statistical analysis of the probability of radioactive decay, it was found that each radioisotope has a unique decay constant, which is the probability of decay for each nuclei. Rearranging this, we find that at a given time, the disintegration rate of a radioactive isotope is equal to lambda n. Integration of this differential equation gives us the more easily manipulated form. Changing the subject of the equation allows you to solve for a number of things. You can simply rearrange to find the size of the original sample, or rearrange like so, then undo the exponential using the natural logarithm. From here, you can easily rearrange to find the time or the decay constant. A very common application of this equation involves using or finding the half-life, where n is equal to half n0. You can use this to establish the half-life, or again to find the decay constant. Finding t is useful in many fields, notably playing a central role in the development of scientific method within archaeology, importantly establishing absolute dating rather than relative. It has helped us better understand our own history, as well as placing this within the entire history of our Earth.
The implications of radioactive decay. Radioactive is basically part of the Earth. Radioactive has existed from the very beginning. Naturally radioactive materials are present in its crust, the floors and walls of our very own homes, schools or offices, and as a matter of fact, in the food we eat and drink. There are radioactive gases even in the air we breathe. Our own bodies, muscles, bones, and tissues contain naturally occurring radioactive elements, including potassium-40, carbon-14, radium-226. Exposure to low levels of radiation won't have immediate health effects, but can cause an increase in the risk of radioactive radiation and will cause some harm to health. When human exposure to radiation in large amounts, it can develop cancer or cardiovascular disease. However, if the amount of radiation is controlled, it can be used to treat cancer by killing the cancer cells. But if a leak or accidental exposure occurs, it would be nearly impossible to control the exposure. Radiation can also cause birth defects in humans and animals. Hence, an exposure to radiation in the wild could lead to generations of difficulties throughout an entire ecosystem. Man has always been exposed to natural radiation from the Earth and also from outside the Earth. We use radioactive substances a lot in medicine, like X-rays and traces. X-rays are part of the man-made radiation which is used to diagnose diseases and cancer therapy.